So now we're going to look at transformations of trigonometric functions. This may be a review from grade 11, except now we're dealing with radian measure. So the following transformations are applied to the graph y equals sine theta. So we have a vertical stretch by a factor of 3, a horizontal compression by a factor of a half, a horizontal translation pi over 6 units to the left, and a vertical translation 1 unit down. So use the transformations above to sketch the graph of the transform function. So our a value comes from the vertical stretch. So it's being vertically stretched by a factor of 3, so our a value is 3. The horizontal compression by a factor of a half is actually a k value of 2. A horizontal translation, pi over 6 to the left, gives us a p-value of negative pi over 6, and a vertical translation 1 unit down gives us a q-value of minus 1. Subbing these parameters into our sine function gives us the following equation. Y equals 3 sine 2 times x plus pi over 6 minus 1. So first we need the base graph of sine to develop our table of values. So here is the base graph of sine. Starting at x equals 0, the sine graph has a height of 0. Then going 90 degrees, or pi over 2 radians, it has a max at 1. Then at pi, it goes back down to 0. 3 pi over 2, it goes down to negative 1. And then at 2 pi, we end up back at 0. Next, we're going to take these x and y values and apply our transformation formula, which is x over k, so in this example it's x over 2, plus p, which is minus pi over 6. Our a value is 3, so then we have 3y, and then plus q, and in this example our q value is minus 1. So let's start with x equals 0. At x equals 0, we get a... Alright, starting with the x values. So 0 divided by 2 minus pi over 6 gives us minus pi over 6. Let's go to pi over 2. So let's do a little bit of algebra. Pi over 2 divided by 2 minus pi over 6. That's equivalent to pi over 4 minus pi over 6. Using a common denominator of 12, I end up with 3 pi minus 2 pi all over 12. So we end up with pi over 12 for our next x value. Our next one is pi. So pi divided by 2 minus pi over 6. Common denominator 12 would give me 6 pi minus 2 pi all over 12, which is equivalent to 4 pi over 12, which we can simplify to pi over 3. The next one is 3 pi over 2. So 3 pi over 2 divided by 2 minus pi over 6. That is equal to 3 pi over 4 minus pi over 6. If we take a common denominator of 12 again, we end up with 9 pi minus 2 pi all over 12. So this gives me 7 pi over 12. And then finally for 2 pi, I have 2 pi divided by 2 minus pi over 6. And let's say we keep the common denominator as 12. I end up with 12 pi minus 2 pi all over 12, which is 10 pi over 12, which is equal to 5 pi over 6. So why did I keep these as 12? Notice that goes from pi to 4 pi over 12. So that's an increase of 3 pi. The next one goes from 4 pi to 7 pi. That's an increase of 3 pi. And 7 pi to 10 pi. Again, an increase of 3 pi in the numerator. So it's still following a pattern, and that's how you can check your work. So our next one is to determine our y values. So if I sub in 0, I get minus 1. If I sub in 1, I get 2. If I sub in 0 again, that's our minus 1. Negative 1 will give me negative 4. And 0 will give me back a negative 1. So last step is to graph this function. So here's my y-axis, And here is my x-axis. First thing is to start with your first point, negative pi over 6. So you need to decide on a scale. I'm going to count by pi over 12s. And you'll see why. So counting by pi over 12s, so there would be negative pi over 12, negative 2 pi over 12. So I go negative 2 pi over 12. That gives me negative pi over 6. So that's where I'm going to start. And then going in the opposite direction, so pi over 12 will be here. So you can see why I chose pi over 12, so I can see that point. So then we have 2 pi over 12, 3 pi over 12, 4 pi over 12, which matches this point here. So 4 pi over 12, remember, is equivalent to pi over 3. So that's this point right here. Then we can do 5 pi, 6 pi, 7 pi over 12. That's the next one we need. So there's 7 pi over 12. Then 8, 9, 10 pi over 12, which is equivalent to 5 pi over 6, our last point. So now let's add our points. First point, negative pi over 6 and minus 1. So let's say that's there. Pi over 12 and 2. Pi over 3 and negative 1. 7 pi over 12 and negative 4. And then back up to 5 pi over 6 and negative 1. So remember, this is a sinusoidal function, or the sine function. So try to draw two parabola-looking shapes connecting together. So there is one cycle of my sine function. So let's state the period, amplitude, and equation for the axis of the transform function. So first of all, let's start with the period. That's how long it takes to complete one cycle. Two ways to find this. First of all, we can just look at our graph, and so our period is equal to 5 pi over 6 minus negative pi over 6, which is equal to 6 pi over 6, which tells us we have a period of pi radians. Formula you might have learned last year, but in degrees, is that the period is equal to 360, but in radians that would be 2 pi divided by the magnitude of k. And again, notice our k value is 2, so we end up with 2 pi over 2, which is equivalent to pi. Next is the amplitude. So the amplitude of the graph goes from what's called the axis of the curve, or the equation of the axis. So let's highlight that here. So the line that sort of separates this into two parts. So this distance from the axis of the curve to the peak or to the trough of a sinusoidal function is called the amplitude. And we can see the amplitude in this one goes 1, 2, 3 squares. So we see the amplitude is 3. So it's 2, the highest point, minus the axis of the curve, which is at negative 1, and that gives us an amplitude of 3. But a quicker way to state the amplitude is just to look for the a value. So the amplitude of a sinusoidal function is equal to the a value, the stretch or the compression factor. And finally is the equation of the axis. So going back to the graph, it's right here. The line y equals negative 1 is the equation of the axis. That is the q value for a transformed graph. Alright, so let's go through this one more time. So this time I'm going to give you the equation. It's negative cosine x over 2 minus pi over 8 minus 2. First off, before we can graph this, we have to put it into the correct form. So y equals negative cosine. We need a k value. And we see that if we factor out 1/2, there's our k value. We're left with x minus pi over 4. So what are the transformations that are applied to the graph of y equals cosine x? Well, starting with the a value, first of all, it's reflected across the x-axis. Next is a horizontal stretch by a factor of 2. And then we have a translation pi over 4 units to the right and 2 units down. I'm missing an arrow here. Our formula to convert each of the points is 2x plus pi over 4 and then negative y minus 2. We need to start with our base cosine graph. So remember, cosine starts at 1, goes to 0, down to negative 1, back up to 0, and then back up to 1. So let's start with the x values. Our first one is pi over 4. Our next one is 2 times pi over 2 plus pi over 4. So 2 times pi over 2 plus pi over 4. And that is 2 pi over 2 plus pi over 4. And that's equal to 4 pi over 4 plus pi over 4, which is equal to 5 pi over 4. And then you can show that the next x value is going to be 9 pi over 4. And hopefully you see a pattern now. 13 pi over 4. And then the last one will be 17 pi over 4. Notice the numerator increases by 4 every time. The y values you'll end up with is negative 3, negative 2, negative 1, negative 2, and negative 3. Alright, so let's sketch this graph. So let's draw our x and y axis. So here's my x-axis. I see all the numbers are negative, so I'm going to throw this a little bit higher up. Here's my y-axis. First off is the scale. So since our first x value is at pi over 4, let's try it and see what happens. So there's pi over 4. Then this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, and this one here would be 5 pi over 4. So it seems to give us a good scale. 6, 7, 8, 9 pi over 4, 10, 11, 12, 13 pi over 4, and 14, 15, 16, 17 pi over 4s. Next we need to define our y scale. So I'm going to choose y values. I'm going to count up by halves for the y scale. So this would be negative 1, negative 2, negative 3. Finally, we just plot our points. So we have pi over 4 and minus 3. So that's down here. We have 5 pi over 4 and negative 2, 9 pi over 4 and negative 1, and then we finish plotting the rest of our points. So there is a flipped cosine graph, stretched and translated. So next, let's state the period, amplitude, and the equation for the transform function. So the period of this function is 2 pi divided by k. In this case, the k value is 1/2, so our period is 4 pi. So that's the distance from here to here. That's 4 pi, the length of one cycle. The amplitude is the a value, so we see the amplitude in this one is 1. And if we were to draw the axis of the curve here, we would see that this amplitude here is 1. And we see that the equation of the axis is that y equals negative 2. So let's review some of the information we now have. A, or the magnitude of A, gives the amplitude of our graph. 2 pi divided by the magnitude of k gives the period, or the length of one cycle. P gives the horizontal translation, and y equals q gives me the equation of the axis. Here are a few questions you can try, and good luck.